Welcome to the Robot Millennium movie on plate analysis, showing in this case how to analyze and design a flat slab structure. We're first of all going to define some geometry for the slab. In this case we're defining the geometry inside Robot, but of course it's possible to define geometry, for instance in CAD, and import the CAD geometry directly into Robot. Having defined the geometry, we can now assign some structural attributes to the geometry by defining, as we term in Robot, a panel. So here we're going to define some materials, some thicknesses, and so on. So a 200mm thick slab. And we can also define, according to various codes of practice, in this case the BS code, exactly the covers of reinforcement and the concrete type that we wish to use. Having defined the geometry, we're now going to decide to input an opening inside the panels. We're now going to start to define some supports. So, first of all, a nodal support. And then a line support. On the nodal support, we're actually going to define a size of column. This column can be defined as rectangular or circular. And also define a wall. We can now apply these two definitions to the structure. For the wall and for the column. Now to define some load cases and some loads within those cases. We're now going to define some surface loads. And in Robot, it's important to remember the loads are applied to the shape of the structure. They are not applied to finite elements. Therefore, changing in the geometry of the finite elements does not affect the loading in any way. So again, we'll define another patch load on the second panel. And now some line load, maybe representing a wall above. Having defined our basic loads now, we can now add some live load. In this case, a UDL over the whole of the slab. And a different live load on the second panel. We can now cycle through and look at all the different loads that we've applied. We can now combine those loads. And we can combine them as ultimate limit state or serviceability limit state loads. This becomes very important in the design of RC structures because Robot has the capability of calculating at both ULS and SLS level. And now a serviceability limit state combination. We can use this case, or all serviceability limit state cases, to calculate the cracked deflection and also cracked width on the structure. And now view our combinations graphically. So now to generate some finite elements. Look at meshing options and we can control the number of elements and the density of elements in various parts of the structure. We're going to use emitters on this structure to radiate elements from holes and from corners of the structure. Like so. We can now calculate the model and look at the results in some detail. For instance, in maps we can plot bending moment diagrams. It's also crucial to realize that in Robot we can plot the results in any direction, not just global directions, but any directions. And in doing this, we can then match the direction of the bending moment in the direction of the reinforcement. Of course, Robot will also calculate the areas of reinforcement that we need, if necessary by using the wood and armor method, which converts torsion in the slab into equivalent bending moments in two orthogonal directions. And then plot the areas of steel that we need on the model, both in top and bottom of the slab, in each direction. And there are our areas. As we mentioned earlier, it's also possible to plot serviceability results, such as deflections and cracking width. And obviously see the results in some tables. We can now use the provided part of Robot to predefine our own reinforcement on the structure and also verify punching shear for our columns. So in this case we can calculate the structure. And now recalculate our structure and view our punching shear requirements at the bottom. In this case, we have a factor of safety of 2.86, according to the British Code in this case. And also we can plot zones of reinforcement